All right, welcome back. Today we're going to talk about the chain rule. Now, the chain rule is used for a composite function, right, or a function inside of a function. So we're going to call both of these f and g, and we assume that both f and g are differentiable, and the function inside the function, or the composite function f of g, right, or we could rewrite it like this. We're assuming that both of those are differentiable. All right, and kind of our formula for that, we have f of g of x, right? When we take that derivative, it's going to be equal to f prime of g. All right, so we take the derivative of the outside, leave the inside as it is. All right, and then all of that is multiplied by your derivative of the inside. Sorry. Okay, so you have two functions, right? Function inside of a function, outside and inside. Taking the derivative of the outside function, leaving the inside alone, multiplying all that times the derivative of the inside function. All right, so I like to write it outside inside. I think this makes it a little bit easier. All right, we're taking the derivative of this whole thing. So derivative of the outside. Leave my inside alone. Multiplied by the inside. All right, inside prime of x. Had to squeeze that on there. All right, so that's pretty much it. And we'll definitely go through a few examples here. All right, so chain rule, we're taking the derivative of a composite function inside of another function. And our formula for that is derivative of the outside, leave the inside alone, and then multiply all that times the derivative of the inside. Let's get into a few examples. All right, so here's our first example. All right, I got the chain rule rewritten up here. And we want to find the derivative of y equals the square root of x to the fourth plus 1. So a lot of times with these, when we see a root, I want to rewrite that. So I would rewrite this as x to the fourth plus 1, all raised to the 1/2. All right, radicals are awful things, so I try to rewrite them as much as possible. All right, now we want to find our outside and our inside. Let's see if I remember which color I had for outside and inside. I think we had green for outside. So I'll just indicate that as out. All right, my out is this whole thing raised to the 1/2. All right, so let's call this inside part u, and just say u raised to the 1/2. All right, our derivative of the outside prime, well, this is just simple power rule, right? Bring down the 1/2, minus 1 up top, and you get 1/2 u to the negative 1/2. All right, do the same little chart with our inside. My inside here, x to the fourth plus 1. Inside prime. Well, this is another simple power rule. Bring down the 4. I have an x to the third. This guy goes to 0, so we don't need to worry about that. 4x to the third. All right, so our derivative of this, like we said earlier, it's going to be derivative of the outside, leave the inside alone. So I'll write that first. Remember, all that's the negative 1/2. All right, we leave the inside of that alone. Fourth plus 1. All right, and then all of that multiplied by derivative of the inside. All right, so that's times 4x to the third. All right, now we can simplify, clean this up a bit. 1/2 times this whole mess gives you 2x to the third. All that times x to the fourth plus 1 to the negative 1/2. All right, and if we want to get rid of that negative exponent, we could simply rewrite this guy as 2x to the third all over square root x to the fourth plus 1. All right, and this would be your answer for that one. All right, so one more example here. I want to find the derivative of 8x to the third plus 5, all of that raised to the third. All right, so our outside here, similar to the last one. All right, we'll call it u again, u to the third. All right, taking the derivative of that for our outside prime gives you 3u to the second. For our inside, all right, we have our 8x to the third plus 5. All right, power rule for that guy again. Bring down the 3. That becomes a 24x squared. Derivative of 5 on its own is 0. All right, so now we're just using that same formula. Derivative of the outside, leave the inside alone, all that times derivative of the inside. So our outside would be 3. Our u is in here, all that to the second. Leave the inside alone, 8x plus 5. All right, all that times derivative of the inside, 24x squared. Okay. All right, now we just simplify this guy. 3 times 24x squared gives me 72x squared times 8x plus 5. All right, all of that raised to the second. That's your answer. All right, let's add a trig function into the mix for this last example. We have the derivative of sine of x squared plus 4x. All right, so we follow the same steps here. All right, our outside is going to be the sine function. So we'll say sine of u. All right, derivative of sine is cosine. So we got cosine u over here. Find the derivative of the inside, our inside function, x squared plus 4x. Derive that guy. Now we get 2x plus 4. All right, same way, setting it up the same way. Derivative of the outside times the inside, all of that times derivative of the inside. All right, so our outside prime, cosine, leave the inside alone. Oh, I messed up my colors. Hold on, let's get it back. X squared plus 4x, 2x plus 4. Sorry about that. X squared plus 4x. Right, we're leaving the inside alone. All of that times derivative of the inside, 2x plus 4. Okay, so we simplify that guy a little bit. Not really much you can do. I like having this term out in front. Times cosine x squared plus 4x. All right, if you really wanted to, I guess you could FOIL, but you know, this is pretty sufficient as an answer there. All right, and there you go. Chain rule plus 3 pretty simple examples, enough to get you started. Thank you.